Hello friends, today's videos were interrupted, that's why we are making two videos for today's sessions. First of all, I will continue the remaining part of the first videos. We are on the synthesis of indole 3 acetic acid. Indole 3 acetic acid, the most important is the starting materials. Most important is the starting material. While writing any reactions, starting material is very much important, because as you return the starting material, as you reminded the starting material, then the remaining part can automatically edited, have conversion or adding the another chemicals or any compounds in that starting material, you can get the final products. So for that, starting material is reminded is very much important. For that, you have to know the starting material of each and every reactions. It is the most important part, because if you not reminded the starting material, if you reminded wrongly another material as a starting material of indole 3 acetic acid, at that time you write down that wrong methods of preparation another of the wrong products. Totally 100% answer will be the wrong. So the starting material is very much important. So in the indole 3 acetic acid, starting material is the phenylhydrazine. Starting material is the phenylhydrazine. So while writing the starting materials, reaction will be with the aldehydes. Reaction with the aldehyde, there is a coupling reaction takes place, formation of intermediates, then the removal of the H plus ions, and the formation of the next intermediates, means it is completed, will and finally we will get the products indole 3 acetic acid. So finding this indole 3 acetic acids, we are passing through the number of steps, means first step, second step, third step and fourth step. This is the first step, this is the second step, this is the third step and this is the fourth step. So these are the four different types of steps we are following, means it is simple process. You have to remind only steps in the reactions, because only slightly changes in the reactant molecules, and finally cyclization process takes place, means the cycling process takes place. 5-member nitrogen containing rings forms along with the benzene rings, and this is your final product, that is indole 3 acetic acids. Indole structure we will get, indole means benzene ring attached with the NH3, it is called as indole. For example, this is the benzene ring attached with the, this is the indole ring. Okay, this indole ring, an acetic acid 3, 1, 2, 3, indole 3 acetic acid, here is the acetic acid. This is the acetic acid, this overall structure is the acetic acid structure. Okay, this is the indole ring. If you know the structure of indole 3 acetic acid, you can remind and find the reactant also by practicing. How we can find the reactant? Very simple. If you know that this is the indole acetic acid, if you know the product structures indole 3 acetic acid, then you can easily form by looking at these structures, because in that structures only this part is not in the reactant part, nitrogen containing part is there. Okay, so compare this product structure with the reactant structure, you will easily get some links. Here is the link is that this reactant molecule and this product molecules having this benzene ring common, then nitrogen, here is his nitrogen, here is the nitrogen is the common, means the, if you know the structure of indole 3 acetic acid product, then you can remind that the reactant having the some similarity with the products. Some similarity is that benzene ring is the same in the reactant, nitrogen is the same in the reactants. Means the, if you know the reactant, if you know the product, you will guess that what if you know the reactant, you can guess that the product having the benzene ring and nitrogen containing ring. If you know the product, you can guess that the reactant having the benzene ring and nitrogen containing open chain. So by using these hints, by using the reactant, you can find out the product. But if you know the product, then you can find the reactant react with the various steps. This is the hydrazine phenyl hydrazine structures. Okay. So by using this phenyl hydrazine structures, you can easily obtain this final product compounds. Okay, that is acetic acid, indole acetic acid. This CS3 CS2 C double bond OH get from the aldehydic groups. Okay. So here is the one step. In that step, we are adding this CS3 C double bond OH group. This step is the this. Here is the adding the ClCS2 C double bond OH. This group on this indole groups. So indole, we know that in the SYBSC we have studied the, that is the heterocyclic compounds undergoes the nucleophilic substitution reactions. In that nucleophilic substitution reactions, nucleophilic substitution site is 3 positions. Okay, 3 position is more preferable than the 2 positions, means the 3 1 2 3 3 numbers. Here is the nucleophilic substitution takes place. Hydrogen is replaced by CS2 C double bond OH. Here is the group is the Cl CS2 C double bond OH. This group is going to be add on the indole heterocyclic compounds. Why this is chosen? Because this CS2 is the substitution site CS2 attached with the one leaving group Cl. As the any group attach on this group, CS2 Cl group is leave from that place, and CS2 C double bond OH is attached on the this ring. This is structure in that CS2. This is the structure in that CS2 C double bond OH attach here. You can easily find out the ClCS2 OH adding on the indole rings. We will get the CS2 attached on the indole rings. So we will get the final products. Okay. In this way, we can easily make the product indole 3 acetic acid. So do practice minimum 3 to 4 times. Do the practice. If you do the 3 to 4 times, first time you write by completely watching the structures. Second time some part remind, some part copy. Third time you try to remind total 100% part, write down and then find out your mistakes with the original one. Fourth time you can easily write. Fifth time you will get the you will easily and without mistake you can easily draw that structures or this synthesis process completely. So this is your works to complete at your homes. This is the must, because it is the first mechanism of synthesis. In the next lectures we are studying the another, means day by day number of reactions are increasing. So the you, as we finish the one part, you have to complete it by doing the maximum practice. Then it will be easily and it will be helpful to further reaction to study the uses. What is the use of indole 3 acetic acid? Indole 3 acetic acid is naturally occurring plant, means of the auxin class, natural occurring plant. It is the effect as the endosine cell, elongation of the cell division for the plant growth and developments. It is promotes the absorption of the flower and the fruits. It is natural, but if any plant is not growing at that time, the externally it is spread on that plant. So that is acquired, it's a required heights or required developments. So the friends, today we will stop here. In the next lecture we will study the synthesis of indole 3, indole, the synthesis of indole sulfans. Thank you very much.